recording. Right now I'm using my laptop as a microphone because I'm charging my microphone. I am going to have potentially a microphone I can walk around with in the future. We've got this new fancy board. All right, so once again, if you cannot see what I'm writing as I write it, you're going to want to be logged into Google Meet so you can see it on your screen. If for some reason you need to go back and fill in your notes, you missed something that I wrote, you'll be able to, once I upload it online, you'll be able to access what we did in class. And so what your responsibility is to do as we go through a regular class lesson, your responsibility is to fill in the answers to all practice questions. When I ask you to work on something, try it yourself first. You can use pen or pencil. I suggest probably using pencil when you're trying it yourself, and you can use pen when you know, okay, this is definitely the answer as we go along. So here we go. Disregard the timer because I gave you the additional bell work and I already put up a timer. This timer was just built into the lesson. The question is from paper 1. Paper 1 is what type of paper? You all remember? Multiple choice. So this is the multiple choice paper. And this is an old question. And this is something that I felt fairly confident that many students would be able to potentially remember from pre-Ace, but maybe not. In which species are the numbers of protons, neutrons, and electrons all different? So what does that mean? Well, first of all, what's a species? Maybe it's an element. These aren't all elements, though. It's either an element or an ion or a compound or an isotope. And so if I don't want to specify, this could be an element, this could be an ion, this could be a compound, this could be an isotope. I say species because I'm just saying this thing. But we don't say thing in chemistry. We wouldn't write that on a chemistry exam. We would write species or substance, something that sounds more scientific. So it's in which of these things are the number of protons, neutrons, and electrons all different? So let's go ahead and remember. And yes, you should. Anything I write on the screen is something you should be adding into your notes to go back and be like, oh, that's what that means. Yes. You can move up. There's seats more to the front. Yeah. You need to sit up closer. Please do. As I said, don't be shy. If you need to sit closer to the front or you need to log into Google Meets, my goal is that everybody is learning. All right, here we go. How many of you got an answer that you think is right? It's a scary question, right? How many of you got any answer, but it may or may not be right? Okay. I'll tell you the answer first, and then we'll go back and go over the reason why. Just to self-assess yourself, the answer here is D. So you can now either pat yourself on the back and say, I'm amazing, or you can say, uh-oh, I definitely misread something, or I don't remember something. All right, so I'm going to reteach this now. If you didn't get the answer, if you did and you weren't quite sure. The number at the top here, this is an isotope symbol. The number at the top here, it's going to have a fancy name you're going to learn later in this lesson, but I'm going to give you the pre-Ace name. It is called the mass number. The mass number. And it's basically the total mass of the species. So it's the mass, all of the mass. All of the mass is located in the nucleus of the atom. So it is equivalent to your protons plus your neutrons only. So your protons plus your neutrons add up to become your mass of your atom. So we know 27 in that is the mass, both the protons and the neutrons. What about that bottom number? What's that called? That's the atomic number. And that is equal to what?
The neutrons?
Not the neutrons. The protons. It's equal to the protons because the protons are the identity of the element. The protons is the only thing that changes from element to element is the amount of protons. And so we know now for sure that we have 13 protons and we have 27 protons and neutrons. And so what I will ask you to do is go ahead and write this out. P-N-E. P-N-E. P stands for proton, N stands for neutron, E stands for electron. If you want to use the official symbol, you would do P with a plus and E with a what sign?
Minus.
Minus. How many protons? Here then. 13. We can now quickly identify the neutrons. How?
27 minus 13.
Right. So it's always subtract the top number minus the bottom number when you see it in this way. 27 minus 13 is 14. Because remember, these have to add up to 27. 13 plus 14 is 27. Now, how do we get the electrons?
It's the same as the atomic number, but if it has a negative or positive,
Then it changes. Right. Protons are positive. Electrons are negative. So if there is no charge, which means there's no number at the top, the amounts are the same. So we know for aluminum, we have how many electrons? 13. So we know this can't be the answer because it says in which species are the number of protons, neutrons, and electrons all different, and they mean all different from each other. Meaning every number for proton, neutron, electron, all different. So we know now that it's not going to be A. What else can we now quickly take out? There's another one that you could quickly take out. C. Take C out now. Why? Protons we know are 16. And because the mass is 32, this means that the neutrons must also be 16. Are you allowed to use a calculator in this class? Yes. Please do. No calculator shame, first of all, even if it's adding or subtracting. Cambridge allows you to use a calculator. Use it. It'll speed up your process. Does anybody need a calculator to use in class today? I can pass the On a regular day, just feel free to grab one from the front and return it at the end of class, okay? If you don't have one with you on any given day. Once again, my concern is you learning. So if you don't have a resource on a given day, not a problem. I have enough for everybody. You have? You need? Alrighty, so we know it's not C. Do I have to evaluate the electrons once I see these two numbers are the same? I mean, you can if you want, but you're wasting time on a Cambridge exam. Once you know it's not the answer, it's not the answer. I'll just write this out just so you know the electrons are 18. I'll prove this in a little bit for a different one, but the answer is not C and the answer is not A. So that means it's either B or it's D. I've already answered that it's D. Let's justify it. So how many protons are there in D?
19.
19. How many neutrons? 39 minus 19, which is 20. So those two are different from each other. So far, so good. Finally, electrons. If protons are positive and electrons are negative, and potassium has a plus, and if that doesn't have a number there, what is it, a plus what?
Plus 1.
Plus 1. What does this mean?
Electrons are 18.
Correct. This means that there is one more proton because there's one more positive charge than electrons. Because the charge comes from the balance between the two, which I'll review in the lesson later, but that's the idea. So plus 1 means one more proton or one less electron. So you would subtract 1 when you see plus 1. That's why chemistry is confusing. You actually have one less electron, which is 18. So that's it. All these numbers, 19, 20, 18, are different. All right, so that's an example of a paper 1 question. At what I would say is level 1. And I'm going to give these questions levels as we go along. Level 1 means this is about as easy as it can be. This is not considerably a complicated question. This is a question 5 on a 40-question paper. Yeah, this is not what they would consider a complicated question. Maybe you needed to review, of course, the ideas, but overall, besides a little bit of weird wording here, it's overall kind of straightforward in what you need to do. So going over atomic structure, I've actually already started to go over atomic structure when looking at that bell work, but we're going to go over it more in detail now. So what you're going to need to know for everyday lessons is I am going to print the lesson objectives before we get started. You're going to see a slide that has the lesson objectives. These are the syllabus objectives. Now, many of you have been in several ACE courses, or you are in several ACE courses this year. So you know what the Cambridge syllabus is. I can put it up on the Google Classroom, and you can look it up yourself. It's 150 pages or something for chemistry. And so I feel presenting it right at the beginning is very, very overwhelming. And so I break it up a little bit at a time as we go through the year. Last class that I was here on Thursday, I ran you through kind of the gist of what you needed to know from the syllabus in terms of what papers you'll be tested on and what those papers sort of look like. But we'll be going over and reviewing all of that over and over again throughout the year. So there are about 180 objectives this school year to go through. That's a lot, right? 180 objectives. We have to be done by pretty much the second week of April to be on track. On top of covering those 180 objectives, we have to go through labs. We have to go through different styles of labs on top of it. All of this I'm telling you to tell you that we hustle in this class. There is no free day. You can consider Monday your pre-ACE practice review bracket. That was your free day for the entire year. Except for like Turkey Bowl. Like we have this class on Turkey Bowl day, so good for you. that ends up being a free day. But other than that, I'm committed to being here every day the rest of this year. And we will be doing something every day the rest of this year. So are we doing something important in this class? Always. It's either a lab, a lesson, an activity, but something that's going to help you through the year. We got a lot of ground to cover. This class moves fairly quickly. It is most likely the fastest paced class you'll have this school year out of the classes that you take. So we have to get through all this today. Count that amount of objectives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 180. Why am I giving you so many? Why do you think I'm starting off with so many objectives? If I give you 10 objectives every day, we'd only need 18 classes to finish everything, right? But there's no possible way to cover all the material we have to cover in 18 classes. Let me be clear. Yes. Question.
I was wondering if there was like a scrub or something. You're trying to watch the thing.
I don't have a scrubber. Sorry.
All
Which
right.
class? For Alonzo?
Yeah.
Sorry.
All right. Thank you, man. Wait, it's not 90 days.
Okay. We have 90 days, but you don't, because that includes like May and June. You have less than that. You have about probably 60 good class periods to get through the material. So on average, we have to cover 3 a day. On average, we have to cover 3 a day. So why would I be covering 10? Well, first of all, because this is an easy topic. And what you're going to notice is the easier the topic is, the more I'm going to cover. If you see a day where you see one objective, what does that mean? It means not necessarily that it's super hard, but it is something that requires time. So it could be something that's more mathematical in nature, that requires more time for practice and explanation. And so there, you'll see days where you have more standards. That means we got a lot to get through, but it's all going to be more surface level. And then if you see less standards on a day, that means that it's more complicated, what we're going to be learning. And so that's just kind of a guide, so you know. The next thing I'm going to do is I'm passing out, this goes for your binder. There's a 3-hole puncher. You can 3-hole punch at the end if you need to. Something called the ACE command words. These apply for every ACE class, and definitely for chemistry. When you're taking a Cambridge exam, you are going to be given different questions, and how they word the question means everything. There's a difference between being asked to describe, being asked to explain, being asked to list, being asked to calculate. And so keep these command words handy for when you're doing the homework, so you know what exactly you're being asked to do when answering a question. Exams can be worded this way as well. And so you'll see, for example, define straight up means you have to give a word for word definition. Determine means you have to figure something out. It means you have to probably do some kind of, in this case, it's calculations, which we showed in the bell work. We'll go back over this again. Define, again, means memorize. So whenever you see define, this means straight up memorize, word for word. Whatever Cambridge says the definition is, you literally have to memorize that word for word. If you don't memorize it word for word, you can just say, I don't have that mark on the test. If they ask me that question, I won't know it. But that's what define means. Describe, it means you're going to tell what's going on. Understand, it's probably for something like a multiple choice question. If it says understand, it means you have to understand this idea in order to answer a question correctly. And so let's take a look at what I want you to do today, just to get in the practice of this. Look at each of these standards and see what you know and see what you don't. I'm going to read them out. We're going to take a look at them. It says, understand that atoms are mostly empty space. There's a very small dense nucleus that has your protons and neutrons, and your electrons are found in the shells in the empty space around the nucleus. If you already know that, put a check mark. Like if you came into this class and you're like, yes, I know that. If you don't know that, put an X. Figure out before each lesson what you already know from either previous or a class before, or what is brand new information to you. The second one, identify and describe protons, neutrons, and electrons in terms of their charges and their relative masses to each other. Do you know what the charge of a proton, neutron, and electron is? Do you know what the mass is in comparison? That a proton is 1, a neutron is 1, and an electron is close to 0. 1 over 1,836. We'll see it in later today's lesson. But close to 0. Negligible. If you remember that, you put a check mark. If you know you need to go back and know that, then you put an X. So check mark means I am already good here. I know this. Another reason why we're covering a lot of standards today is there's a lot of stuff in here that is review. Understand the terms atomic and proton number, mass and nucleon number. So if you know what atomic number is, you know what mass number is. I did briefly go over it in the bell work. You put a check. If this is something you don't remember or never learned, you put an X. Do you know where the mass is in an atom? Do you know where the charge is in an atom? If you do, check. If you don't, X. This is all the stuff we're going over today. So hopefully it's not looking too crazy. The next, I would assume that almost everyone's going to put an X on because this is the only new standard of the day, I believe. Describe the behavior of a beam of protons, a beam of neutrons, and a beam of electrons moving in an electric field. If you know what that is, put a check mark. If you have no idea, put X. I'm going to assume that most of the class, because I definitely didn't teach that last year, it's going to be an X on that. Determine the number of protons, neutrons, and electrons present in both atoms and ions. This is the bell work. If you remembered the bell work on your own, like how to do that process, put a check. If you did not remember that, put an X. It means you have to review it. Do you know off the top of your head what an isotope is? Do you know what an isotope is? If you can answer, I'm letting you think about it for a minute. Do you know what an isotope is? Do you remember? Could you say it off the top of your head?
Isn't it having more or less neutrons than the stable?
The stable. The last word. You got the right idea. Stable element. So atoms of the same element that have a different amount of neutrons specifically. That's an isotope. If you can remember that off the top of your head, it's a check. If you're like, no, I gotta go memorize that, you put an X. Understand this notation. This is the notation that was used in the bell work. If you recognize that notation and were able to use it to figure out the mass, the atomic number, you put a check. If you don't remember it, you put an X. So you're doing for yourself. Checks if you know it, X if you don't. If you don't know it, it's okay, but you gotta learn it. State and explain why isotopes have the same chemical properties. And so these are gonna be sort of new as well. And so these are probably new covered today as well. So those are probably X's. So then count your checks and count your X's, and that's your starting point for the first topic. There will be some topics where you know a lot of material coming in. There will be some topics where you know nothing coming in, and that's okay. But just kind of a self-assessment to see where you're at. If you see you got a lot of X's, pay attention. We are going to go over everything today. And if you got a lot of check marks, still pay attention. There's stuff to add. All right. So here we go. This is the periodic table Cambridge uses. Many of you should recognize it because it's the one I print and laminate for all the tables. Those will be going out soon. So you have them at your tables. While you're waiting, I bought you a little periodic table to use. You can either use that one when you're doing your homework assignments, or you can use the periodic table here. I also think I asked the sub to give you a periodic table. I think I had them give you one. So you should have that one with you as well. This is the one you get on the Cambridge exam. So this is basically your periodic table Bible. You get this on the Cambridge exam. It'll be the last page of the exam is the periodic table. You can't rip it out, unfortunately. It's bound to the exam because those of you who've taken exams before know that it's kind of like bound. The last page printed on the back is the periodic table. So you have to flip back and forth to get to it when you take the Cambridge exam. Yes?
Question, but why is the hydrogen like over, like in the middle? Or is that just for absolutely no reason?
So hydrogen is a nonmetal. It has one valence electron. Therefore, as a nonmetal, it should belong over here because nonmetals are over here. But it has one valence electron, just like a metal, which would place it right here, which is where most American periodic tables place it. Cambridge is like, no. We're not going to do that. We put it in the middle because hydrogen's unique. And so basically what that ends up being is when you learn things, you learn the rule, and then you learn the rule for hydrogen is its own unique special element. Yes? Yeah, go ahead. Grab that. You should go ahead and do a favor for yourself. If you have a periodic table, do this on your Cambridge periodic table before we even get started. It's the one thing you should write. Or if you have your one from last year, you can take it out. What did I just write? What does that staircase represent? Metals versus non-metals. So metals, and the other direction is non-metals. Write that for yourself. We do very little discussion of metalloids in this class. We kind of pretend they don't exist. Metals, not metals. Next thing, group charges. You should start this class knowing your group charges. Every element in group 1 has what charge? 1. Plus 1. When it becomes an ion. So in order to become an ion, it has to give away 1 electron because it only has 1 electron to get. Everything in group 2 is plus 2. Group 13 is plus 3. On the other side, group 18 is, I gotcha. Group 18 is, group 18 is 0. These are noble gases. They don't bond. They don't give away electrons. They don't receive electrons. They're chilling as is. They're single. Yeah, they're already stable. So the point of gaining or losing electrons is to become like a noble gas. If it already is a noble gas, you don't need to gain or lose electrons. So 0. So everything in group 17 is -1 when it becomes an ion. Group 16, group 15, Through 14? Plus 4 or minus 4. What makes the decision there? If it's plus 4 or minus 4. Right. Metals, positive. Non-metals, negative. That's the decision. Metals will make positive ions. Non-metals, negative ions. Because non-metals gain electrons, metals lose electrons. Yes. The other one? I'll see. I have it in your notes printed. Let me check to see if in the materials from the sub, if I was left with that. Yes. Because I still have to laminate and put them out at your table, but I do have some. Anybody else want a Cambridge periodic table, or you lost yours from last class? You need one handy? Yes? Anybody else want the Cambridge periodic table? Anybody else? You're good? You're good over here? All right. So let me go ahead and get your attention again. Here we go. This periodic table has some information already on here for you. Just a reminder. The atomic number, there's a key here. The atomic number is told to you. For every box, you're set, they tell you the atomic number's at the top. The top number is the atomic number. So you know how many protons every element has by looking at the periodic table. The atomic symbol told to you. This, if you are coming to this class from not CIE or you took chemistry somewhere else, creates chemistry, the next thing is such a blessing. You are given the name of the element. They didn't have to do that. A lot of periodic tables don't include the name. They only include the symbol. You're told the name and the symbol of every element. So utilize the periodic table. It's there. They provide this for you. And then the bottom, relative atomic mass. We'll spend some time, and we did in 3A's going over it, but relative atomic mass. Notice it is not the mass number. You may want to write that for yourself right now. Remember those mass numbers when we were calculating protons and neutrons and adding them up and getting whole numbers? It is not the same as the relative atomic mass. Why not? Anybody remember? Go ahead.
Isn't it the mass of the most stable isotope of the element?
What's the mass of all of the naturally occurring isotopes? It's the average of the mass of all the isotopes on the planet for an element that are naturally occurring. It's that average mass. So what does that mean? If you were to do calculations, you cannot use relative atomic mass for mass number. You cannot. So you're going to get questions where you're asked to calculate the mass number. It is not reading it off the periodic table. Do not read mass number off the periodic table. That's just something to know in advance, because these numbers, and you could tell here, they're decimals. You cannot have 0.5 of a proton. You cannot have 0.5 of a neutron in an element. They have to be whole numbers. So these decimals, for now, you're going to disregard those numbers at the bottom. When we get to moles, we'll circle back to what this is, because we'll need that information then when we calculate large amounts of compounds and elements. All right, review time. Some things you should know. Turn your page. In order to be called an element, there can only be one type of atom. If there's more than one type of atom, you've got a compound. How can you tell the difference if you're looking at a chemical formula that you have an element or a compound? What are you looking for? Number of
Elements.
capital letters. Every capital letter indicates an element. Every time you see a capital letter, it means it's a new element you're looking for. So if you have one capital letter, you have an element. Look it up on your periodic table what it is if you haven't memorized it. If you have two or more capital letters, what does that mean you have? Multiple elements. And what do we call multiple elements together? A compound. Capital C, carbon, capital I, capital L, lowercase I. You know you're looking for one element on the periodic table, lithium, capital F, lowercase e, iron, capital K, potassium. One capital, one element to look for. Multiple capital letters, you're looking for a compound. Notice the bold and underlined term on this page. That is something that you can technically be asked a definition for. I don't really see them ask for this definition, but just in case. An atom, so you should put little brackets around it because this is a possible definition. It's the smallest part of an element that can take part in a chemical change. We used to say it was the smallest indivisible part of an element, but it is divisible. Does anybody know how you would divide an atom, what that is? If you divide an atom, how do you do that? Nuclear fission. Nuclear fission. It's a nuclear reaction. In order to split an atom, it goes beyond the scope of this class. It is a nuclear reaction. It's physics, really.
So,
But it can be done. So Oppenheimer, yes. Also note that radioactive elements, they can naturally decay into other elements. In previous chemistry, I take the time to go over this topic, but it's not in the ACE curriculum, unfortunately, because it's very interesting. All right, so first question, answer this over the next 2 minutes. See if you get it right. Try it yourself first. Determine whether each of the following is an element or not. So answer it on your paper. It's a yes or no. Yes if it's an element, no if it's not, or check an X. Just check to see if you can recognize elements versus compounds, basically. And then for those that are not single elements, you are being asked to say how many different elements are present. So these are guided notes, meaning you answer as we go along, you fill in as you go along. A, is it an element? Yes. CaO, is it an element? No. How many different elements are there? I should say bonus points, covalent or ionic. Don't stress if you don't know that, but it is in a future unit not too far from now. Ionic, metal and a non-metal. We'll get there. It's not on the first test. NaCl, yes or no? No. How many elements? Always confusing. 2. C with what looks like a capital I is not a capital I. It is always a lowercase L, and it is chlorine. This is Cl. Capital I and lowercase L look almost identical to each other. This is 2 elements. It's sodium chloride or table salt or just the extra salty one. I. It's literally like 1 letter, so it has to be an element. No. The answer. I did that on purpose, by the way. The answer to no is yes. Yes. It's nobelium. 1 capital letter element. What about no? With a capital N, capital O. No is no. The second one. This is 2 elements. Nitrogen and oxygen is nitrogen monoxide. Naturally produced in the atmosphere from lightning. You're going to learn that later this year. Crazy. FeNO, what? FeNO3 too? No. Fe no? No. How many elements here? 3. Bonus points again. What's this thing inside of the parentheses?
Polyatomic ion.
Polyatomic ion. You know the name?
Nitrate.
Nitrate. It is on the things I asked you to memorize, but I said don't stress if you haven't memorized it all yet. It won't be on the first test. But it is things you need to know this year, basically. Like coming into that unit, when we get to the unit where we need to know naming, you'll need to know that NO3 is nitrate for sure. All right, so we're feeling okay about elements and compounds. Good review. Next, sketch and label an atom. So let's pick an element of the periodic table, but let's not get too crazy. Let's pick one of the first 10. You can go up to 20, but for your own safety, don't go past 20. Pick an element, any element. Raise your hand if you want to go over one specifically. Go ahead. Beryllium. Okay. Beryllium. We're going to do Be94. So this isotope. Be94. Sketch and label an atom. If you are asked to sketch and label an atom, we're going to use something called the Bohr model. It is a 2D. Let's see if I can erase. 2D representation. It's not the best, but it's what we have for being able to give information. The electron cloud model is the best, but it's too complicated. Cambridge won't ask you for it. So if you're being asked to sketch a model, you can do the Bohr model. The Bohr model is the one where you start with the nucleus in the middle, and then you build out the energy levels. So for beryllium, how many protons are in its nucleus?
4.
Okay. So you're going to write a nucleus, and you're going to write 4 protons. P plus, P plus, P plus, P plus. 4 protons. How many neutrons?
5.
5. So 1, 2, 3, 4, 5. Just 5 neutrons. 4 protons, 5 neutrons. Total number of particles in the nucleus?
9.
So mass of 9. Now what do we have to do?
Draw the electrons.
Draw the electrons. Now, I haven't officially taught this lesson yet, right? That's actually coming up later. But in energy levels, we may as well just start getting comfortable with it now. The electrons, are they inside the nucleus?
No.
No, they're in the electron cloud outside of the nucleus. They exist in distinct energy levels. And so we write those, if we're using the Bohr model, we write those as rings. And so the first energy level, you write it as a ring, like that. How many electrons fit in the first energy level? And again, it isn't officially part of this lesson. To get this right, all you have to know is that all the electrons are on the outside of the nucleus. But we may as well just do it anyways. It's 2. There's 1, 2, and you can literally count the first row of the periodic table. The amount of elements there is how many electrons as well that can fit in that specific energy level. So row 1 actually represents energy level 1. You could fit 2 elements, you could fit 2 electrons. And so you get an electron and you get another electron. Yes? How many electrons in total does beryllium have?
4.
We've already accounted for 2. So all we got to know is put another energy level and put how many electrons there?
2.
And so you just put 2 electrons in the same energy level and you've done it. Diagram complete. Everything has been labeled because we labeled them in the diagram. Proton, neutron, electron. Yes?
What's the number of electrons that can fit in the second energy level?
8.
8.
That is, I believe, on Friday's lesson, but yes, 8. It's 2, 8, 18, technically. All right, so going back to when we asked, it said, where's the diagram 1? The distribution of mass and charge within an atom. That's going to be 1.1.4. We now know that all of the mass is where? Mass is in the what charge does the nucleus have?
Positive charge.
Completely positive, right? Because the neutrons don't take away from that positive charge. So the nucleus has a positive charge as well. So where's the negative charge in the atom?
Outside.
So outside the nucleus. And that's all we need to know at this point. It's outside the nucleus is all of the negative charge. And if it's an atom, the amount of positives will equal the amount of negatives in total. So 4 protons, 4 electrons. The reason you should write this is because if a multiple choice Cambridge question comes about, they can ask questions about the mass and charge distribution in an atom. That's where I usually see it, is in the multiple choice questions. And drawing the diagram is to help us understand. A little bit more time, then we're going to move forward. The next slide will be really quick, hopefully, if you all remembered. Protons are positive, neutrons are neutral, and electrons are negative. Right? P plus, E minus. In this class, you have to know how positive and negative charges work. If you're bad at negative numbers, you're going to struggle a bit because electrons are negative, and so everything you think is always opposite when it comes to electrons. So make sure that you have the charges of protons, neutrons, and electrons. The other thing, and so we already kind of did this. You do not have to memorize this, so you can put an X here. You do not have to memorize this. I've got it in the textbook, but you don't have to memorize this. You don't have to memorize this. Something you do need to know. The new name for mass number is nucleon number. So nucleon number is the same as the mass number. Nucleon means inside nucleus. So actually, it makes more sense. Inside the nucleus, the particles in the nucleus are the nucleons. So protons are considered nucleons, and neutrons are considered nucleons. So the nucleon number is all of your protons plus all of your neutrons. It's the same thing as the mass number. Yes.
Why didn't we learn that last year if it's like a better way?
Because of those students who are not taking this class but are going to take it in America, because it's not mentioned in America.
Oh, so just a bunch of words.
Yeah.
So
By
So nucleon means particle in the nucleus. So all particles in the nucleus are called nucleons. Yeah, the other place where you'll see that it'll be a different terminology is molarity. It's slightly different. You'll see in this class. If we have a particle in a nucleus, we call it a nucleon. So we call protons nucleons, we call neutrons nucleons, but we do not call electrons nucleons because they are outside of the nucleus. So that's important to note. Yes.
I asked you this last year, but are neutrons a little bit denser than protons?
They are. So the masses are, it's like 1.008, if I recall, versus 1, if you base it off of one of them. But we round. We round to the whole number here. That matters if you study like particle physics. It definitely matters. All right, structure of the atom. The atomic number actually also has another term, which you're going to see it written. This one's an easy one to remember. The proton number is the same as the atomic number. This is easy to remember once you remember that the atomic number is the amount of protons. So if they ask you for how many protons are in a element or an ion, they could ask you what is the proton number. What is the number of protons? It's the same thing. It's the atomic number. So it's always the whole number associated with an element. Orbitals we're going to learn in another class period. But if you recall the letters SPDF, it's coming. It's coming soon. The electrons are held in areas of space called orbitals. The electron cloud basically breaks into different potential energies, and that's where electrons are held. That's not for today, though. The next thing is that weird standard. The weird standard that nobody's seen before, because I don't think it's really relevant in the previous material, and I'm wondering when they're going to take this out of the AS curriculum, because Cambridge has been changing the standards to like update it, and this might be one that it's first of all not tested very often, and it falls more into physics. But as many of you know, chemistry is like in the middle of biology and physics, so sometimes we'll get something that's really a physics topic, and sometimes we'll get something that's more on the edge of biology. In chemistry, we call it the central science. Anyways, in physics, physics works a lot with charges, electrical charges, and then also magnetism. And so a magnetic field will deflect electrical charges. The way magnets work and how charges work as well is positive charges. If I have two of them, do they connect? Are they attracted to each other, or do they repel? So like charges repel. So you're going to want to write this down, because this is actually one of the major ideas in chemistry as well. If you don't understand this, it's a bad time the whole year, because we do a lot with charges. Like charges repel, and opposite charges, they attract to each other. And you're going to need to understand this to understand this kind of weird standard. So what Cambridge is asking for you to know is how do beams of different particles operate in an electric field? This has to do with some of the history of chemistry. How they were able to determine that there were electrons in the first place was with a cathode ray tube. And they did this in the late 1800s. They figured out, oh, that's how we know there's electrons and they have negative charges, is because of the behavior of how the charges interacted in an electric field. So this goes into some of the history, but you don't have to memorize the history. You don't have to tell that. You just have to know, if you see a beam, what does it do? Does it attract? Does it repel? Or does it do nothing? So let's go over that. Oh, that's so nice. This is, for those of you who don't know, this is a new TV. I was on a really old smartboard for a long time, and I was just projecting everything on my iPad and teaching off of my iPad. And so whatever I was teaching would go to that screen. And so GIFs just like didn't work right. Nothing worked right. So I'm like, oh, it's actually doing the thing. How cool. It's moving across. All right, movement of a positive charged particle in an electric field. Take a look at what's happening here. The particle is the little ball there. What do you see is happening? So it's going like this. You should draw this too. Go ahead and draw this because it's not moving on your slide. What's happening with the positive charge? It's moving away from the positive plate and moving towards the negative plate. So all you have to recognize here, and you will have to draw, is if you see a beam of protons, it's going to be angled away from a positive plate and towards a negative plate, because like charges repel and opposite charges attract. So you should write that down. So this is the proton beam.
If the beam was going slower, would the line be sharper? Or is that not how it works?
Not quite. I will tell you how the line works actually a little bit more in a bit. I'm holding off on a piece of information until I explain both protons and electrons, because there's something additional you'll need to know. But for now, just know it goes down. There should be, for electron, we should show electron. If I didn't do a separate one, let's go ahead and show that. What if I had an electron beam? And let's just start it here. What if I have an electron beam? What would it do? It will move towards this side, right? And we'll have a third one. There's protons, there's electrons, and there's neutrons. And so what would happen if I had, and let's just write it here, neutron beam. Would it go towards the top?
No.
Would it go towards the bottom?
No.
Wherever you started, it would just go straight through. This is the neutron. This is the electron. And this is the proton. I've seen this worth as much as 3 points on a paper too, which is actually nice. If you know the standard, it's actually really easy. You just draw the lines and label it correctly. If they don't label the plates positive and negative, you have to know one side's positive, one side's negative. You can pick either side. You just have to know one side's positive, one side's negative, and that creates the electric field. I want to point out one thing. It's going to show up in the questions in a little bit. The electron, I tried to write it, the electron curve is sharper than the proton curve. The electron curve is sharper than the proton curve. I'm going to write that here. The electron curve is sharper than the proton curve. And you actually do have to write that if you were asked on a Cambridge exam. You would have to curve your electron curve visibly more than your proton curve. Why do you think that might be so? Why would the electron curve be a sharper curve than the proton curve? Go ahead. Yes, that's exactly correct. Electrons have way less mass than protons. Something that's heavier doesn't move as far. So because protons are heavier in mass, they don't move as far. We're going to answer that question officially later on, but you've got it. That's correct. I'm going to give you a little bit more time to write this up, and then we'll continue. While I'm waiting, paper 2 is your written paper, right? Do you know if you have to write it in pen or pencil?
Pen.
All written papers are written in pen, meaning for those of you taking chemistry, you will write your work in pen, except for the multiple choice paper. If you're taking math, the same is true of math. ACE math, you must write everything, all your math in pen. Just if you haven't been told yet, so I'm setting you up now to know, all your math will be done in pen. And I do know you have, I want to apologize. I have talked to Ms. Sauerowitz. I want to apologize that you have math and chemistry back to back with each other. For those of you that have chemistry and math, it's 4th period, 6th period.
You're making it sound bad like that. Me and David had it too.
I will coordinate with her to try not to put tests on the same day. We have had a conversation already because it's a bit rough. But just mentally prepare yourself each day because you'll be learning a lot in each class.
You said protons are slower than electrons.
They're
faster than neutrons, right?
You don't have to describe the behavior of protons versus neutrons, just protons versus electrons. All right, so let's answer a few questions. A lot of times if you see a question here and it doesn't have the Cambridge writing, that means that I got it from the Cambridge textbook. So this comes from the Cambridge textbook. You're told some information here, and they tell you that a huge voltage must be applied to deflect a proton beam. It's a different way of saying the same thing I told you. It will take more effort to move a proton beam than to move an electron beam. What does this tell you in the difference between a proton and an electron? So let's go ahead and officially answer that here. Protons have a greater mass. And we should use the word mass, not weight. Why?
Weight is dependent on gravity.
Correct. So get the word weight out of your mind in this class. Whenever you want to say weight, write mass. Mass doesn't take into effect gravity. Mass is the measurement of how much of an object there is, regardless of gravity. Do you think that a neutron would be deflected by a cathode ray? Why or why not? So we know that the answer is no. And the reasoning is neutrons are not charged and would not be deflected as a result. I'm not trying to scare you about the math. I'm just saying I'm aware that you have math before this class. I can't change the way I run the class except trying to coordinate the testings. Other than that, you've got to learn what you got to learn here. Yes.
But like, if I have a question that we have to like do the lines, are we? I know for environmental we're allowed to like use pencil to sketch it, and then
For graphs and diagrams, you're allowed pencil in all science classes. Yes, for graphs and diagrams only. That matters most for the lab. But like math has to be done in pen. Calculations have to be done in pen. It's gross. All right. So summary of masses and charges. You actually have to memorize this information. You should mainly know it from pre-ACE, but if you don't, it's a good reminder. The relative mass of an electron is what? Oh, that's the hardest one. Let's do relative charge first. Relative charge of an electron is?
-1.
-1. Relative charge of a neutron is?
+1. Oh,
Proton? +1. Relative mass. Proton is 1. Relative mass in AMU means atomic mass unit. In grams, it's some crazy number like times 10 to the -28. We're not memorizing the grams. We're going to memorize the AMU because those are the easy numbers to work with. Neutron also 1. Electron 1 divided by 1,836. And yes, you do have to memorize that. I have seen this given as a table on a Cambridge exam on paper 2. And it's been worth 3 marks. Where do you think the marks are at? Each row. So it's like this. You get everything about the electron right, 1 mark. You get everything about the neutron right, 1 mark. You get everything about the proton right, 1 mark. So basically, if you know this, but you don't know any of that, it's 0 marks. When they count by rows. That you know all the information about that one specific thing. So just kind of getting into the jive of how you would be graded by Cambridge. When I grade your unit tests, I will grade like Cambridge. So when you get your feedback, you'll know, okay, I got the mark for this, I didn't get the mark for that. So just to give you a heads up, the way that they mark is rows. And it goes like this, 1, 1, 1. Marks are in brackets, like that. You have to know a process. All right, so I'm gonna skip this because I already showed this, skip. We're moving on to calculations. Calculations. So you have the element symbol X. We use the element symbol X to mean random element. We pick X because there is no pure X on the periodic table. That is the reason why X is chosen. We can't choose Y because there is a yttrium. Yttrium is element 39. So random element X. What you do is here is the nucleon number is at the top and the proton number is at the bottom. And so you do have to know that the nucleon number is at the top, the proton number is at the bottom, and you have to recognize these letters. From here, we're going to take a look at calculations, which is where we started the work, actually. We're going to go back and recalculate how do you do protons, neutrons, electrons. And so this time, because I already did explain it, and hey, look, it's there. Yay. Before we get to calculations, this is something that I don't know if you learned this in pre-ACE or honors or you took it virtual. You have to know that there's different types of notation that exist out there. If I'm looking at carbon 14, which by the way is radioactive carbon. We're all a little bit radioactive. It's what they use for radioisotope dating, carbon-14. You could see it written like this, carbon-14. You can see it written like this, the full symbol, or you could see it written C14. And what you have to recognize in any of those is that 14 is the nucleon number. And if the atomic number is not told to you, will you be able to figure it out? If you're given this format, would you be able to figure out how would you find out that carbon's number is 6? If you're told carbon-14, how do you know that carbon's atomic number is 6? Well, you always have a periodic table, so you get it from there. So given that information, these checkups, if it says checkup, it means this comes from the Cambridge text. And so I will solve the Cambridge text questions, or we'll solve them together in class. When I give you homework, which I'm not giving you homework today, I'm going to hold off till next class because I know you had that packet, so I didn't want to overwhelm you with work. I already felt bad giving you all those practice questions, so you will get homework next class, actually, on this lesson and the next lesson. But go ahead and solve this out. See if you can do this based on what we've learned. Use the information in the following table to deduce the number of electrons and neutrons. So fill this out. You've got a few minutes, and then I'll go over it with you. Fill out the chart. Fill out the chart that says check up 2. And then we're going to go over it together. Include the electrons, the neutrons, and the isotopes. What I miss about my computer is knowing what slide I'm on. Okay. All right. It's 1:50. I'm going to go ahead and start reviewing. Check to see if you got it right. Vanadium, electrons, 23. Neutrons, 28. Symbol, V, 51, 23. You don't include the neutrons at all in the isotope symbol. It's the combination of the protons and neutrons on the top for the mass, and on the bottom, it's just the protons. Second, electrons, 38. Neutrons, 84 minus 38, is that 46?
Yes.
Anybody? Okay. And then here, this will be 84, 38, SI. Phosphorus. Electrons. Neutrons. Isotope symbol. And 15. All right, we feel comfortable with this? This is something we're remembering or understanding? Let's do one on the next slide. I'm going to leave this up for about 20 more seconds. Let's do one on the next slide just to see the other way a question could look. And then we're going to talk about ions before we leave. We got to get to ions and isotopes. All right. Let's pick one of these. For fun, let's do palladium. Why not? Palladium 110. We're only going to do one of these. Write the isotopic symbol for palladium 110. Where's palladium? So you got PD. Top number is actually 110 because this is the mass number or nucleon number. So you've got 110 on the top. And what number goes on the bottom for palladium? 46. We picked that up from the periodic table. So the top number you would actually get from the written symbol. The bottom number you get from the periodic table. The atomic number you always get from the periodic table. And so that's all we're going to do for neutral atoms. I just wanted to show you one. You don't have to do all of these. You can do extra ones if you want on your own time, but I just wanted to show you the idea of what you would do. Isotopes. Do you remember the standards? We have to memorize this definition. It said in the standards, when we reviewed the standards, you just straight up have to memorize this. It said define. So put this on your, I have to memorize this. This means Miss Fleet might on your next unit exam literally write define isotope as a definition. It is a 2-mark definition. 1 mark is to say that you have atoms of the same element. So underline that. The second mark is different amounts of neutrons. So that's how it breaks up. So you first have to say atoms of the same element. So different versions of the same element, that because they have different amounts of neutrons. That's what makes it an isotope. I can hear you. Make sure you're ready as we go along. So what you'll notice is that the masses are different. This means there are some properties of the element that are the same and some properties of the element that are different. And so I'm going to skip this for sake of time. But what you would notice is that there would be one nucleus that had 2 more neutrons than the other nucleus. That's the difference between the two. What I do want to do is show you some Cambridge questions. So this is from the 2020 exam. It says gallium is a metal in group 13. There are 2 stable isotopes that exist. You are being asked to state. So underline that command word. I gave you a paper of command words at the beginning. State. With reference to subatomic particles, how they're different from each other. So how will we state, with reference to subatomic particles, how the isotopes are different from each other? Are you missing a page? I can give you the back of mine. It's just this last one. Thank you very much. Welcome. All right. So, what do we mean by subatomic particles? Go ahead.
Protons, neutrons, and electrons.
So, one of these are different. Which one's different?
Neutrons.
Neutrons. So we know that when they say with reference to subatomic particles, we are being asked to state the difference in the amount of neutrons. So let's take a look at gallium. How are these specific isotopes different from each other? What I would do if I were you, notice there's a number at the top, but no number at the bottom. Why don't you figure that out? The mass doesn't. The atomic always stays the same. So the idea you're saying is correct. What I would say is to write a 31 here for yourself so you can help explain. Because they're asking you to reference that element specifically. So if you just say an isotope is when we have atoms of the same element with a different amount of neutrons, you get 0 marks. Have you made an incorrect statement? No. Have you answered their question? No. You have to answer the question. The question is, how do these two differ from each other? So let's go ahead and do that quick calculation. For gallium, 69, how many neutrons does it have? 38. For gallium 71, how many neutrons? So our correct answer would be to say that gallium And you could just write the symbol, or you could say gallium-69 has 38 neutrons, whereas or however, gallium-71 has 40 neutrons. And so you are specifically stating how the neutrons are different in these two isotopes. Do you see the difference? This is not asking for you to define isotopes. It's asking for you to apply your knowledge about isotopes using this specific example. This is which paper? So we're just getting comfortable with which paper? This is paper 2.
For chemistry questions, you want to make the answer as short as possible.
For chemistry, your English teacher might tell you something different. For science, we are very direct. We don't add fluff. We say what needs to be said, and we stop. Don't add extra information. Don't talk yourself in a circle. You will lose points. They will give you something called like a negation, where you originally had it, but then you kept talking, and then you said something that contradicted what you said before, and they're like, nope, they don't know what they're talking about. 0. That's the way. So you just get to the point, you answer it, you're done. No fluff for this class. 1 mark means you don't write that much. For most questions, you only see between 1 and 4 marks in chemistry. There's no real essays in this class. Okay, so isotopes. What you need to remember is because they are of the same element, and elements are in the same group of the periodic table, act the same way. If I have the same element, it will always react the same chemically. So all isotopes, they react the same because they have the same amount of valence electrons. So all isotopes, they react the same. No matter which carbon you have, carbon 12, carbon 13, carbon 14, all the carbon in your bones will react the same way in a chemical reaction. They have slightly different physical properties, but they react the same. So I have a short video here. Let's see if it works. It's embedded. I'm still playing with my new board, but I'm going to let you finish writing this first. They react the same because they have the same amount of valence electrons. They have different physical properties. Let's see. No sound? I did mute it. Oh boy, that means I have to do this thing. I have to mute this one, I believe, for that to work. Let's see, Google Meet. So what if an element has a charge? Meaning, you'll have got, in this case, Cl with a -1 charge. What does that mean? What does chlorine with a -1 charge indicate?
Has an extra electron.
Has an extra electron. So chlorine, the atom, has 17 protons and 17 electrons. But as you may recall, all atoms want to be like their nearest noble gas. So they gain or lose electrons in order to become like their nearest noble gas. So chlorine, the nearest noble gases are gone. And so it needs to gain one more electron to get there. And that's what's being illustrated here. If I take chlorine and I add one electron, I get chlorine with a extra electron, which is where we write the -1 charge. Ions or charges are always written at the top right corner. So every part of an element symbol has a meaning. For those of you that are new or you just need a refresher, if I know that this here was my mass or nucleon, this here was my, we learned that it's called the atomic, right? This here is called the charge, the top right corner. What about the bottom right-hand corner? I'm not technically learning it, but what is it? I'm not learning it today. But if I have a number at the bottom right-hand corner, what does that mean? Let me give you an example, H2O.
Is how many?
What does this mean? How many, right? Is the amount of the atom or the element. So you should know the four corners of an element symbol off the top of your head. Because the numbers, where their placement is, we're very picky in chemistry. The number has to be clearly indicated in a specific place for it to have a specific meaning. All right, we're almost done. If you haven't already realized, this class is going to be intense, meaning we're going to go through the whole class period. I have 5 less minutes than I would in another time of the day because they call announcements at 2:15. So you may think that that doesn't mean anything, but in this class, it definitely means something. So I will be hustling to make sure we get through everything we need to by 2:15. There will be some days where you'll have some time for working on assignments at the end, but there'll be more days that are like this than are not like this, where you're basically learning material throughout the whole class period, stopping, working on a question, and then working on more material throughout the class period on regular lesson days. All right, ions. So now you know, if you've gained an electron, you have a negative ion. If you've lost an electron, you have a positive ion. And so the last exercise that we're going to do is back to the beginning where we look at ions. And we're going to do some calculations for ions. If I see something with a charge, I can't call it an atom. That's something you need to be aware of. So if you see this, Cl -1, you cannot call that chlorine atom. What do you call it instead?
Isotope.
Not an isotope. It would be the chloride ion. If you see Na+, can you call that the sodium atom? No, you call it the sodium ion. So that's important to note.
So you have to make sure you don't mess up on that.
If you say sodium atom and it has a +1 charge, you don't get that mark. You have to make sure you're very careful with your terminology. That's why I said you say less. You're very specific and careful about what you say. Yes.
Why does chlorine and IED?
When we go back over naming, that will be better explained to you. But all non-metals change to IBE at the end when they form ions. We're not actually formally going over naming again yet, but to answer your questions, because it's a non-metal. Metals, you don't change the name at all. Non-metals, you change the ending to IDE. only when it's in a compound. And ions are part of compounds. Yes, you probably did. All right, last exercise. This is, I'm gonna walk you through, we already did A, by the way, didn't we? Do you recognize it? Anybody recognize A? Literally the answer to the bell work. So I'm not gonna show you A, I will show you B, and then I'm gonna ask for you to do C and D and show it to me by the end of class. So I'm gonna show you B real quick. What I'm asking for here is the amount of protons, neutrons, and electrons. How many protons are in B? 7. How many neutrons are in B? And so the operation, you don't have to show this for Cambridge, but I'm just going to show it to show you the answer. You would do 15 minus 7 equals 8. So 8's the answer here, 7's the answer here. And then electrons. 3 minus actually means 3 extra electrons because electrons are negative. So when you see this, it means add 3 electrons to the amount of protons. So it will be 7 plus 3, which is 10. I've seen charts like this on Cambridge exams before as well. They work the same way, meaning you have to get the whole row right for 1 mark. Everything about that element has to be right. All right, so you try C, you try D, show it to me by the end of class, and I'll check it to let you know if it's correct or not, and I will sign off on it. After that, try the other question if you've got the time. There is a paper 1 question there too. See if you can get that one. And I'll sign up on that one too. Perfect. And then try that one. Try both. There's 2 existing questions. One is just the standard textbook question, and the other one is the Cambridge question. Perfect. Great job. Raise your hand, and I'll check off as you show it to me, and then do the other one as well.
29?
The paper 1 question.
29. 28. That makes so much more sense.
These are both.
Remember the 40s, right? Yeah. Yeah.
And then try this question. The paper 1 question. Perfect. Great job. I'm just going to raise my hand. Very nice. That's an 8, right? Yeah, completed. The examiner might say backwards for you. These are good. Yes, the C.
Yes, I figured you. No, I don't need to put all my strength.
All right, I'm coming around and checking. Just to be clear, I'm not giving any additional homework because I gave you that packet due on Friday. If you did already finish it and turn it in, great. If you still have outstanding questions about it and you're done and I've given you the signatures, you can pull that out and ask me any questions about it. I'm also staying after school today if you have any additional questions. I'm coming around to sign right now. Hold on to them. Both of these are good, like C and D are good, and then just try this question. Yeah, come in. Oh, yeah.
Good afternoon, Golden Lions. This is Miss Kaufman. A lot of you have been emailing me about your mobile devices. I just sent a reminder email.
Keep
You need
your
to
notes. They go
forward
in your
me the
binder.
Copy of the
You're done?
insurance receipt.
You're done, or you have
And
questions?
your parent needs
Okay.
to
Yeah,
complete
you
the
do.
mobile device
Very
agreement
good.
online. I processed everybody who has done those 2 steps. If you did not get a computer today and you're anxiously waiting, please go home and make sure that those 2 steps are complete, and I will call you down
You understand it?
tomorrow morning.
Yeah.
Good afternoon, everyone. This is Ms. Garcia. If you are taking a dual enrollment course, this is your reminder that tomorrow, Thursday, is your last day to drop any classes that are short, 8-week terms, 12-week terms. Tomorrow, Thursday, is your last day to drop those classes without any penalties. If you are taking a full semester class, the ones that started in August and don't end until December, the last day to drop those classes is Friday. Again, the full semester classes that started in August and end in December for dual enrollment, your last day to drop that is Friday. If you have any questions, please send me an email